Dear world, welcome back in today's session. Previously, we have studied the array list collections, enum, hashed, hash table, linked list, etc. But in today's session, we'll be studying the map. So before we go deep dive into the map, we will be understanding the map theory. That what is map theory? So this is I have already written the map. So let's make a file first before we move deep dive into the map theory. So let's make a file map example one code map example one.java. So we got a map example one.java and let's declare the file. First we need to import the files. Import java.util, import java.util.star, public class map example one, public static void main string out. So we have made our main file. Look, we always have to name the same name for both the file name and the class name. Our both the file name and class name must be same in Java, else we'll get compile time error. So let's understand the theory. This is Java map interface, and a map contains values on the basis of key, that is key and value pair. That means whenever you understand map, that is actually a key value pair. So from here we can understand that map is actually a key value pair. Each key and value pair is known as entry, and every key value pair in map is known as entry. We call them entry. Well, let us see. So this is how like map. There are a map contains a unique key. A map is for implementing map in Java. First, that is map and sorted map. That means there are a few protocols how we can implement. So these are like interfaces. Interfaces are some things what needs to be implemented. These are not the things like class body. These are what we write in the first portion. So these are the two interfaces through what we can implement the map. First map, and second that is sorted map, and third the classes, that is HashMap. And these are the three classes through which we can declare a map: HashMap, LinkedHashMap, and TreeMap. So before we can use this map, first we need to import those classes. Import those classes. So let's see, start importing by HashMap. So this is map example one. So now this java.util.star package imports all of the packages, but we will only be using this HashMap class, LinkedHashMap class, and TreeMap class. So instead of importing all the packages, we can only import that package. Import java.util.hashmap. Why hashmap? Because we will be only using the hashmap. Import java.util.map. You might be thinking why you are importing the map when we will be using the hashmap class. Okay, we are importing this map because this is the interface, and to implement any interface we need actually perfect class. That's why we will be using this HashMap. So first we'll be using this map interface, and we'll be using this HashMap class. So this is for now. Let's make a string and value pair. Show map, and now we can make any type of map like string. String is the key. The first what we provide here, that is the key, and next what we provide here is the value. String and integer. So we'll be storing string as the key position and this integer at the value position. And let's say we're giving this name as map1. That equals to new hash map. And now look, this is the map interface what we implemented, and we created an object of that interface map1. And through what we implemented, through using the class HashMap. So this is how we can implement the map. And now inserting the data. To insert data we can use the put method. For inserting data we can use the put method. So inserting data using the put method. So map1.put, let's say wiki galaxy, and this is 1. Map1.put, map2.put, wiki code 2. So this is, now we have inserted those elements, and we can also print out those elements. But first let's understand the theory clearly. So these are HashMap and LinkedHashMap and TreeMap. HashMap and LinkedHashMap allows null keys and values. That means HashMap and LinkedHashMap, if we use these two classes, they allow us to use null keys and values. But whenever we use the TreeMap as our class, but whenever we use this TreeMap as our class, it doesn't allow us any null value. That means in TreeMap we cannot store any null value. So let's understand more about the HashMap. What they tell, HashMap doesn't maintain any water. That means if you insert using the HashMap, you will not get any water. That means the water will get different. Like if you insert it, and after inserting they will get 12, 25, 13, etc. And let's say you insert it in the water the 12 first, then 13, then 45, but in HashMap that doesn't maintain the insertion water. Linked HashMap is actual implementation of map inheriting HashMap. Linked HashMap actually inherits this HashMap, and it maintains the insertion order. So if you require any type of HashMap that requires the insertion order, for that you can use this linked HashMap, as it maintains the insertion order. TreeMap. Suppose you need to get a ascending order, and for that you can use TreeMap. Not only TreeMap, even TreeSet also maintains the ascending order. So whatever you use of tree class, tree data structure, they always maintain the ascending order. So these are the hash map, and this is the declaration of hash map, that is map of string, integer, map new hash map, that we have already declared. This is map 1, this is map string, integer, map 1, new hash map. Suppose instead of hash map, if you would like to use linked hash map, we could do that also. Map string. Instead of string, we could also make key integer at the key. Integer string map 2, and now we are using new linked hash map, and now look, we have used the linked hash map to make our map interface object map 2, and for that we have to import the linked hash map class, otherwise we will get compile time error. Import java.util linked hash map. So this is linked hash map. Now let's again make a class of tree map. As you looked here, this is HashMap, this is linked HashMap. So let's understand HashMap. In case of HashMap, we already knew that it only allows null key and multiple null values. HashMap is additionally not thread safe. That means if you are working with multi-thread, so you cannot use the HashMap, as it is not thread safe. But if you use HashMap, the insertion, retrieval and deletion turn, it actually takes big of one-time complexity. In case of linked HashMap, it takes a larger time. So if you want to get fast performance, for that you have to use HashMap. For getting fast performance, HashMap should be your choice over linked HashMap and over linked HashMap TreeMap, because this is the speed order, comparative speed order. HashMap is the fastest. And this is TreeMap, map string, integer, new TreeMap. This is how you store. So we actually knew they are stored in order, and it is actually slower than HashMap. It is written that it is slower than HashMap, and it actually takes log n time complexity for basic operations. So this is about TreeMap. So how? Let's implement the TreeMap also. Map long. We will be actually using long data type string, long string map 3, that is equals to new TreeMap. And as you can see, we have created TreeMap. Now let's compile the file. Before running any Java file, we first need to compile. So we'll be compiling the file using java compile -g dot map example 1 dot java. And look, we got error that string cannot be converted to integer. String cannot be converted into integer. Map 1 dot put. This is a string and this is integer. String cannot be converted to integer. Look, we are getting this error that string cannot be converted in map 2 dot put, but here map 2 dot put, this is string and this is integer, but in our map 2 this is the object of that type, that means integer and string. So we have to change the pattern. Now we'll be changing this pattern. Wiki code, and now we will not get the same error. Again we'll be compiling the file. And now look, we got another error, that TreeMap error, cannot find symbol TreeMap. That means now we are not able to find the TreeMap. So look, whenever we use any map class of Java, we have to import. So we have to import TreeMap also. That's why we got the error. Import java.util .treemap. So this is, we have used the TreeMap. Now again we'll be compiling the file, and now we'll be running the file. Java map example 1.java, map example 1, and now it just run, but we haven't printed anything, so we are not able to see. So for printing the elements, we can actually use iterator of map class using set. So let's understand the theory and we'll be printing one by one. First, the top methods that are used in map interface. The top methods used in map interface are first put. In using this put method, we pass a key and a value. We pass a key and value and they are added. Adds a key value pair to the map. So if you use put method, dot put method, if you use dot map one dot put, arguments 1 comma argument 2 then it will actually, if the keys already exist then it will update, and if not exist then it will actually add. So this is map.put. Retrieves. So using the get method we can actually print any value. So suppose we want to get any value, for that we can use the map.get method. So let's see the map.get method. So integer value equals to map.get apple. So actually we will not get any elements as we haven't added any elements. So let's add this element also. Map1.put apple 2, and now this is integer value system.out.println value. So now we have used now we are printing the value using the dot get. This dot get method actually retrieves the value and we will be printing the value. So let's again compile the file. Cannot find symbol. Sorry, we have inserted the apple in map1 and we are searching map. So map is not available, we have to make on map1. And now Java map example1, and now we can see we got the index 2, we got the value 2. So using this get method, helps us to retrieve the value. Get method, dot get method helps us, to retrieve the value, So this is get method. Now let's move to the third method, remove. Suppose using this remove object key, if you use the dot remove function use a key, then that element will get removed. So first, before removing elements using the dot remove, let's add a lot of elements in this map.map1. Map1.put YouTube 3, map1.put insta 4. So suppose if you want to remove any elements, if you want to remove this insta element, so for that we can use the map1.remove function. For removing any element we can use the dot remove function. map1.remove, and we can just use insta and this insta will get removed, and we will be not able to extract this value using this insta. So again, integer map.get insta. System.out. So previously we have observed working with the map example and map. So in today's example we'll go more deep into the map example. First we'll be observing how we can add elements into the map, how we can create the map. So let's make another file, and to make a new file we'll use code map example2. First let's come into that directory map yt. So command map yt, this is change directory map yt, and code map example2.java. Now look, our file name is map example2, so our class name also must be the same. So first we'll be importing all the libraries. Public class map example2, public static void main string out. So first we will be observing how we can create map. In the theory observed, there were 3 types of map declaration. That means there were actually 2 interfaces. There are 2 interfaces how we could declare the map. So these were interfaces, and there were 3 classes through what we could declare the map. So let's these were the interfaces, map and SortedMap, and the 3 classes were HashMap, LinkedHashMap, and TreeMap, how we could declare the maps. So this is the general format how we can declare the maps. So first, in today's video we'll be making all. Let's make HashMap. We are just simply copying it. Okay, this is map string integer map new HashMap. So we created a map. So we can create another map also like this. Map string. Let's say we'll be keeping integer first. Integer string map1 that is equals to new hash map. Now look, the type is different here. That means map1 and map, these are not same. These are not same. So if you add something to map1, we cannot add that same things to map. So let's try adding elements. And for adding elements, we have previously used the put method. Adding elements using put method. So map1 dot put. First, we have to provide the integer value as we have specified. So let's say 1 apple map 1 dot put. Second, banana map 1 dot put. Third, में we can put, let's say kaju map 1 dot put. For we can say it's let's mango. So this is, now we have put 5 elements to the map. So how can we view the elements? Viewing the elements is really a thing that we want if we want to display our data to the users. So for that we have a lot of elements what we can apply. Either we can use this set method. We can convert the entire things into the set method, or we can use the entry set method of map.entry interface. This is map.entry interface provides us dot entry set method, so we can also use that. So for now, let's use the map.entry set method for map.entry. This is the interface for map.entry, and let's make an object of this m in map1. Look, we have inserted data to map1, so we will be using map1 dot entry set. It will create an entry set of all entries. That will create an entry set of all entries, and entry set is a method, not an attribute. And now let's write system.out.println m dot get key. If you apply the dot get key method, we can extract from this attribute the key m dot get key plus the corresponding value is m dot get value. And now we can see the elements being iterated. So for to run the program, we need to compile the program, and for that we'll use java compile -d dot, that means current directory, file name map example 2 dot java map example 2. And you can see the first corresponding value is apple, second corresponding value is banana. So we got the elements to be printed out. This is how we can print the elements. Now as we have seen printing the elements, we can see the elements comparing one by one using the compare by key method also. Suppose we want to see all the elements in streaming format. So for that we can use the dot stream method, and inside the dot stream we can sort using comparing by key etc method. So let's check how we can print the elements in another method, and through that we can sort also by using comparing by key, comparing by value etc attribute. So let's start streaming the methods. So now we will be screening the methods. So this is, let's omit it. Now we will be trying to compare the methods while streaming. For that, first we need to create a map.entry set. And now we created a map.entry set. It will return a set view of the mappings contained in the map. Once we have applied, it will return us a set view of the mappings. It will return us a set view of the mapping contained in the map. It will return us a set view of the mapping contained in the map. And once you apply the dot stream method, it will return a sequential stream with this collection as its source. So once you apply dot stream, it will return a sequential stream with collections. It will return as sequential streams as its collection shows. Now we will be sorting, we will be streaming, that means we will be able to see all the entries one by one, but we can apply here sortings also. That means we can sort as we want. So for sorting we will use just the sorted method, dot sorted method. So this is dot sorted, and now we will be comparing by key, and the comparing by key method comes from the map.entry interface. So we will be use map.entry interface, dot sorted map dot entry. So this is map.entry interface, and now from here we get the comparing by key method. Comparing by key, as you can see. So we got the comparing by key method, and now this will sort according to the comparator we provided. Will sort, look, here we have provided comparing by key, so it will sort according to the key. If we have provided comparing by value, it would sort according to the value. So it sort according the comparator we provided, sorts according to the comparator we provided. So this is dot sorted, performs an actions for each, and now we will be using dot for each method, and for dot for each, and what we want to print all the elements, so we will be using system dot out colon print ln. So it will print for all the elements. So this is a stream we created. Now let's check the stream by compiling the file. Java compile Java map example 2. I don't know why they are not being printed. Sorry, they are not printing because we have no elements in this map. Look, this map is entirely alone. So let's delete this map so that we don't fall in the confuse. And let's make it map 1. And now we'll be able to see the elements. Again compiling. And as you can see, now this is streaming all the elements as we have applied comparing by key. So this is the method of comparing by key. There is another method, comparing by value. It compares by value. This method comparing by value compares by value. So we can apply that method also through streaming. Through streaming we can apply that method also. So let's try applying that method. Map1.entry set dot stream dot sorted dot map dot entry dot comparing by value dot for each system dot out colon print ln. And now we are comparing by values. Let's again compile the file. Java compile Java map example, and you can see we again got the same values because now we have compared here using the value method. Even we can change the printing order also by using comparator.reverse order. Suppose we are comparing by value, so to change the order that they are printing this order, I want the order in reverse order. So for that we can use comparator.reverse order method. We can use comparator.reverse order. As you can see, this is reverse order that we got, and now you will be able to see that we will get in the reverse order. And look, now we got the reverse order. So this is how this streaming is so much beneficial. First we are doing that map on.entry set. We are creating an entry set, and now we are applying the dot stream method that it will be printing one by one all the things. Now we are applying the dot sorted method. By this, using dot sorted, we are sorting the elements. We are sorting the elements based on the comparing comparator we are providing, and this comparing parameter comes from the map.entry interface. And at the end we are using .for each to print all the elements using system.out println. So we have observed till now comparing by key, comparing by value, the descending operator, etc. In the next class, we'll be observing the hash map in more details. So I'm finishing this lesson here. Thanks everyone for observing it.